All right, so today what we're going to do is we're going to do a titration to analyze the contents inside of here. And so I've got a bottle of aspirin, and the bottle claims that there's 325 milligrams of aspirin inside of here. So what we're going to do is we're going to verify that that is what's inside of there, is that that amount is inside of there. And so this is a very practical lab in terms of a real world application, because many times, especially in a field like pharmaceutical, when pharmaceutical companies develop the processes that develop the drugs that create their medications, they want to do quality control by analyzing their production to make sure that they are in fact producing what they are. And so there's some medications that it's actually extremely important that they are very precise and very accurate. And so this process of analyzing to make sure that there is inside the pill what it says there is a very important thing. So let's go ahead and get started. I'm going to go explain what we have here. So we've got our burette. We have a beaker here. Inside there's a magnet. We've got a stir plate there that will actually spin the magnet. I'll show you that in a little bit. We also have our aspirin. We have an extra beaker on the side, and I'll show you that for a moment. And we've got our sodium hydroxide, our phenolphthalein. Now, the phenolphthalein is actually our indicator that we're going to use today, and it's a really great indicator because this aspirin happens to be a weak acid, and so we are titrating a weak acid with a strong base. And if you remember from the titration notes, that actually shifts the endpoint, or the equivalence point up. And so the phenolphthalein will change to pink at a pH around 8.3 or around there. And so that is pretty close to when the endpoint of this is going to be. And so that's why we choose phenolphthalein. Let's go ahead and get started here. All right, so what we're gonna do here is we're gonna put some water in this. And notice that I'm not being very precise with how much water I'm putting in there. I'm just putting in some amount of water. And I point that out because I want to, I'm gonna ask a question later about that. So I'm gonna take an aspirin tablet, we're gonna put it inside of there, and we're gonna give it a little bit of time to dissolve. Now, what I'm doing right here is I am crushing it up with the stir rod, just kind of increasing the surface area, if you will. And it will over time dissolve. Now, what I'll say is there are, when you think about a tablet is not 100% of medication. Really, a very small percent of it usually is actual medication. And most of the rest of it is actually filler that is not going to dissolve. And so I point that out because a lot of this white powder here won't actually dissolve because it's an insoluble filler. There you have it. It is for the most part dissolved. There are, like I said, some there's some part of the tablet that doesn't actually dissolve in the water. It's the part of the filler, like probably stuff like cellulose or something. And so it's going to have like little floaties in there. That's okay. The aspirin itself, the actual medication, is dissolved in there, and so that's okay. So we're gonna put this to the side for a moment, and we're going to then look at our burette. So here's our burette. Right now, I've filled this up above the line there. And so I use my handy dandy funnel to put inside of there to funnel the sodium hydroxide. And so again, this is 0.100 molar solution of sodium hydroxide. But what we need to do is we need to take this sodium hydroxide, and we need to actually bring it down to the 0 mark. And so I'm going to use my extra beaker to do that. Now this here is the bottom of the burette. Now the burette happens to be a very, very precise piece of glassware. It's one of the more precise piece of glasswares that we have here at Round Rock High School. And so anyways, this here allows us to open up the to allow some of it to come out. Now notice how you can actually get it to where you open it up to where it comes out like a nice little stream. And you can also get it to where if you do it just right, it comes out in drops. And so there are certain situations in which you can do a drop. You can put in 1 drop at a time to get really, really close to the end point. And so you can control how much comes out. So you can have it full blown open, or you can have it, just drop by drop. So what we're gonna do is we're gonna slowly open this up, and then you'll see that it will start to go down, and you can control how quickly it goes down. And so we're gonna get it right where the bottom of the meniscus is, right at the 0 mark, and that's about exactly where it is. All right, and so yep, it's exactly where it's supposed to be. So what that means is we're starting at a volume of 0. Now, what we're gonna end up doing is we are going to, first off, this is our extra beaker that we use to bring it down to 0. Now what we're going to do is we are going to put this beaker with the aspirin inside of it on here, and we're going to add enough sodium hydroxide in there to neutralize all of the aspirin. So what we're gonna do now is, again, there is aspirin in here. It is a weak acid, all right? And so what we're gonna do is we're gonna add a couple drops of phenolphthalein. So we'll add a couple drops in there, put 3-4 drops in there. And again, what that's going to do is, right now it's clear. Phenolphthalein turns pink when it's in a basic solution, and specifically when it's in a solution of a pH of 8.3 or greater. Now this is perfect for this particular titration because this is a weak acid in here, and if you remember from your notes, what happens to the equivalence point is the equivalence point gets shifted upwards, and so this is going to make it to where the end point, which the end point is where it turns pink and stays pink, is close to the equivalence point. So what we're going to do now is we're going to turn on our stirrer. And what we're going to do is we are going to put some sodium hydroxide. Now the directions tell us to put 1 milliliter in at a time, but I happen to know that we're going to at least need to put 10 milliliters in there first. So I'm going to go ahead and just put 10 milliliters in there. And notice how it's now at 10 milliliters. The meniscus is touching just the line there. Now again, remember it started off at 0 and now it's at 10 milliliters. And that's because it's telling us, the reason why it's increasing going down is because what it's doing is telling us how much of the sodium hydroxide we've put in. And so that's why it starts off at 0. Now what we're gonna do is we're gonna start adding quantities of 1 milliliter. All right, so we're gonna add quantities of 1 milliliter until we get to a point where it starts to, the pink starts to linger. And so you'll see what I'm saying here. So we're gonna start adding quantities of 1 milliliter. Okay. Do you see the pink there? And so so when you put that sodium hydroxide in there, it turns a little bit pink, but then goes back to clear. The reason why it goes back to clear is because it's still acidic. There's still acid inside of there. The sodium hydroxide is neutralizing the acid when you put it in there, but we have not put enough sodium hydroxide in there yet to neutralize all the acid. And so let's go ahead and add some more. So notice how the pink is lingering. So, okay, so the pink is starting to linger a little bit longer. So it's still lingering a little bit longer. And so what we're gonna do now is we're gonna go by half milliliters. So we've been going by 1 milliliter this whole time. Now we know that we're starting to get to the point where there's not as much acid in the bases, it's lingering around a little bit before it reacts with all the acid. And so let's go ahead and add half milliliter increments. Ooh, and it's really lingering there. All right, it's starting to turn pink and stay pink, but notice how it's really going back to clear. So we're really, really close here. We're really close to the end point. And again, the end point occurs when it turns pink and stays pink. All right, I think we've done it. We've reached the point at which it's turned pink and stayed pink. Remember, I put 10 milliliters in to begin with, and then what I did is I went by 1 milliliter increments, and then when the pink started to linger, I started going by half milliliter increments. And so let's go ahead and see how much sodium hydroxide we put in to reach the end point, which we just achieved right now. So if you take a look here, it's at 17 milliliters. And so it took 17 milliliters to get to the point that it turned pink and stayed pink. Now, go ahead and record the 17 milliliters inside of your data table. And from this information, you should be able to determine how much aspirin is in fact inside of there. Thank you for watching this, and go ahead and complete your lab. You guys have a great day.